Welcome you all. In this video, I will discuss about sum of subset problem. The sum of subset problem, you will be given with one set x which contains some n values, basically integer values, and a sum yes, a value. So you need to find the subset of x, so which sums to the value v. So from this set x, we need to find all the subsets, so whose sum is equal to the given sum yes. Actually the result will be a set. The size of that set is also n. So each value in this result is either 0 or 1. So 0 indicates the exclusion of that particular value to the result. Suppose if this is the ith value, that means the index is I. If that index value stored in that index I is 0, means the particular value in the set x, that means the ith index, the value stored in the ith index in the x is not included in the result. If the value of that result set, the value of the ith index in the result set is 1, means inclusion. So inclusion means that particular value stored in the ith index in the input set x is included in the result. Suppose if you have some 3 the values in the input, the size of the input set is 3. The output set also has 3 values. So what are the possible output set or the possible values of the output? So all the values are 0. That means all the values in the input set x is not included. Suppose if the required sum is 0, this is also one of the possible solution. So and another one is 0, 0, 1. So this means only the last element is included in the result set. That means the sum of the last value in the given input only taken, and so on. It means 0, 1, 0, 0, 1, 1. So this is up to 1, 1, 1. So these are the possible combinations of solutions, and for each combination we need to find the actual sum. This is 0. So this means this combination only includes the last element. So the sum is the value of the last element, and this combination includes the value of the second element. So the sum is also in the second element. So here we only take include second and third element. So the sum of this subset is second and the sum of the second and third element, and here we include all the elements. So here sum is the sum of all the elements in the input set. So for all combinations we need to find the sum value, and we need to return the combinations whose sum is equal to the given value yes. So now if the input size is 3, we can there are 8 possible combinations of the output. So in general, if the input size is n, if the input size is n means there are 2 power n possible combinations of the output. That means there are 2 power n possible subsets can be formed from the given set, and we need to find the sum of all the subsets and only returns the subsets which satisfy the given constraint. That means the sum. So if we solve this problem using this method, then the complexity of this particular solution is 2 power n. We found 2 power n combinations, and for each combination we find the sum. So it takes 2 power n. Now, can we reduce the time complexity using any other method? Yes. So this same problem can be solved using backtracking. So by using backtracking approach, we can efficiently solve this problem. So backtracking we already know. So we start from some initial state. So and then from this initial state, there are several possible next states. So we will move to the any one possible state. So and then from that possible state, we will check whether this is a feasible state or not, whether this state satisfy our constraint or not. If it is satisfied, then we will move to the next 2 possible states which can be reached from this current state. So now I am moving to some other state, and in this state I am just checking again whether this state is feasible or not. Suppose it is feasible, then I repeat the same process. That means from this step I will select any one of the next 2 possible steps which can be reached. Suppose at this state we check our constraint and we found this state is not feasible state. That means the constraint is not satisfied, means I kill this state and move back to this previous state. This is called backtracking. So I just move back. I move backtracked. So once after I backtrack to the previous state, then from this previous state I will move to the any other possible states that can be reached, and I do the same process repeatedly. So from 3 I will check whether it is feasible state. If it is feasible, then I move to the next 2 possible state from 3. If it is not feasible, then again I will move to the previous state 1. Suppose if all the possibilities of that state 1 is explored and none of the next state is feasible, means I need to kill the state 1 and then I move back to the root node, and from that I will select any other possible next node that can be reached from our initial state. So this is the actual working of the backtracking approach. So now, how this same problem can be solved by using the backtracking approach? I will explain this with one example. So this is the input. The input contains 6 elements, and we need to find the subsets which sum is equal to 9. So in the backtracking, we need to start from the only empty state. So and then we should find some constraints also. In each state, we will check whether the constraint is satisfied or not. So here for that constraints, I am using 2 values. So one is sum, and another one is remaining sum. So and then in each state I need to calculate the sum. Sum means the sum of all the elements which are included to that particular state. So this is the intermediate sum, the sum of all the elements which are included up to that particular state. And remaining sum is the remaining sum that can be included into this subset. So this is the two values that are used as a constraints for our solution. So initially the sum is the initial state, that means empty state, the sum value is 0. That means we are not include any values to our subset. And the remaining sum means so in this, from this step I can add all the elements in the input. So it means it is the sum of all the elements in the given input, that is 3, 37, 41, 51, 53, 58, 60. So 60 is the remaining sum. So this is our initial state. The sum is 0 and then the remaining sum is 60. So from this I am moving to the next state, next possible state. So in this state I am going to add the first value. That means in the result set the first value is 1. That means the first element in the given input is added into the solution. So after that, once I add the first element, now the sum of this subset, that means this subset contains only one element, this 3, and the remaining sum is, so all the other elements can be at this particular state, all the remaining elements can be included. So the remaining sum is 57. And in each state the constraint we need to check is the sum at this state should be less than the required sum. Yes. Okay. So the sum at that state should be less than the required sum, and the sum plus remaining sum. So sum plus remaining sum should be greater than the required sum. So these are the two constraints that we need to check at each state. So the sum up to that level, that state should be less than yes, and then that sum plus the remaining sum should be greater than yes. These are the two constraints that we need to check. And what is the solution state? So solution state is the sum at that particular state should be equal to yes. If we find any state at which the sum is equal to yes, then that is the solution state. So these two constraints we need to check whether sum is less than yes and sum plus remaining sum is greater than yes. Okay. So in this state I am checking that constraints. So sum is less than 9. So here the required yes is, so at this state the sum is equal to 3, which is less than 9, and then the sum plus remaining sum, 3 plus 57 is 60, so which is greater than 9. So we can, this is a feasible state, we can move further. And from this state I am moving to the next state. So I am moving to the next state where x2 equal to 1. That means I am also going to include the second element. So after including the second element, the sum will be, already the sum is 3. Now I am including the element 34. So now 3 plus 34, that is 37. So and then remaining sum is, I am including the element 1 and 2. So the remaining sum is excluding the elements 1 and 2. That means 60 minus 37, that is 27. So the remaining sum is 60 minus 37, that is 23. So now I am checking the constraint. So sum, now in this state the sum is 37, so which is greater than 9. So our first constraint fails. So this state is not a feasible state. So I just kill this state. So this means I am not going to explore any states, possible states, 1 sum x. That means all such possible combinations are killed. That means like this 1 1 0 0 0 0, 1 1 0 0 0 1, so etc. These all possible combinations are just killed in this state itself. So now I backtrack to the previous state, and from this I am going to, so from this now I am going to explore some other possible states. That means x2 equal to 0. So x2 equal to 0 means I am not going to include x2 now. So the sum is the same 3, and the remaining sum is not same, because in this particular combination I am just excluding the value 2. So the value 2 cannot be included. So we need to subtract the value of 2 from the remaining sum in the previous state. That means 57 minus 34. So 57, this includes the value, second value 34. Now we find that the second value cannot be included in this particular combination. So we need to eliminate that value from the remaining possible sum. So 57 minus 34, this is 23. So the remaining possible sum is 23. So now I am checking both the conditions. That means sum should be less than yes, and then sum plus remaining sum should be greater than yes. So here s is 9. So sum is 3, which is less than yes, and 3 plus 23, 26, which is also greater than yes. So now it is this feasible solution. So from this I am moving to the next possible solution, that is x3 equal to 1. So I am just trying including the third element in this subset. So after including the third element, so up to now we include first element and we exclude the second element. So the sum is 3 and the remaining sum is 23. So now I am adding the third element. So third element value is 4. So now 3 plus 4, 7. So third element value is 4. 3 plus 4 equal to 7. And then remaining sum, now from this remaining sum I am adding value 4. So the remaining sum will be 19. So 23 minus 4, that is 19. So now I am checking whether this is feasible. Yes, 7 is less than 9 and 7 plus 19 is greater than 9. So this is also feasible solution. So from this I am moving to the next possible state, that is I am trying to include the fourth element, inclusion of fourth element. So the fourth element value is 12. So I am trying adding the fourth element 12. So already the sum is 7. So now I am adding 12. So this will be 19. Already the remaining sum is 19. From the remaining sum 19, so that 12 value has been added. So 19 remaining sum will be 19 minus 12, that is 7. But here the first constraint, the sum should be less than 9, that is failed. So this condition is not a feasible state. So it should be killed. So I am backtracking to the previous state. So in this from this state, the next state, exclusion of, I am trying excluding the fourth value in the result. So if I exclude the fourth value, then the sum will be 7 only, because fourth value is not included. So sum will be 7 only, and the remaining possible sum. So with fourth value, the remaining possible sum is 19. Now the fourth value cannot be included. So in the possible remaining sum, we should not add the fourth value. That means 12 should not be added. So we need to eliminate it. So 19 minus 12, this will be 7. Now I am checking whether these two are possible. So this state is feasible state or not. Yes, sum is less than 9 and sum plus remaining sum, 7 plus 7, 14, that is greater than 9. So the both the conditions are satisfied. So this is feasible state. So from this I am moving to the next state. So next state, I am just adding the fifth element. So I am just adding the fifth element to our result set. So if I am adding the fifth element to the result, then the fifth element is 5. This is the fifth element, so 5. So I am trying adding the 5 in the current subset. So already the sum of the current subset is 7. So 7 plus 5 is 12. And the remaining sum of the current subset is 7. Now I am adding a value 5. So the remaining possible sum is 2. 7 minus 5, 2. So now I am checking the feasible conditions. So 12 is not less than 9. So 12 is greater than 9. So that first condition itself failed. So I just kill it and moved back to the previous state. And from this previous state, next possible combination is excluding the fifth element. So if I exclude the fifth element, then the sum will be same 7, and then the remaining sum. So already the remaining sum contains 7, and we are deciding that the fifth element cannot be added. So from the remaining possible sum, we need to subtract the value of the fifth element. So the value of the fifth element is 5. So 7 minus 5, 2. So now next possible state is I am adding the sixth element to my solution. So inclusion of the sixth element. So after including the sixth element, already the sum of this subset is 7. Now I am adding the sixth element. So the value of the sixth element is 2. So now I am adding this to my solution. So now it becomes 7 plus 2 is 9. Already the remaining sum is 2. So from the remaining sum I added the value 2. So now the remaining sum is 2 minus 2, that is 0. So now I am checking the sum 9 is equal to the required sum 9. So this is our solution state. So for reaching this solution state, I am using x1 value is 1 and x2 value is 0 and x3 value is 1 and x4 value is 0. So here x1 value is 1 and x2 value is 0 and x3 value is 1 and x4 value is 0 and then x5 value. So x5 value is 0. And finally x6 value is 1. So x6 value is 1. So from our input I just added the first element. So first element value is 3. So first element value is 3 and then I am adding the third element. So third element value is 4 and then I am adding the last element or sixth element. So sixth element value is 2. So now it gives you the subset whose sum is 9. So if you repeat the same, once you reach the final solution state, still we can do our recursive backtracking approach. It means move back to the previous state and then explore all its possible next state. So if you complete the entire state space tree, then we can able to find all the possible solutions. So some more possible solution. So this, for this input we can also find another possible solution like 4 plus 5. That means the output state set will be 0, 0, 1, 0, 1, 0. So this is also another possible state. This is one possible state and this is another possible solution. So if you complete this entire state space tree in this way, again backtrack to the previous state and explore all the possible combinations. So we can able to find all the possible solutions of this sum of subset problem. So here, without this backtracking, we need to explore 2 power n combinations to find the subset whose sum are equal to 9. So if you use by using the backtracking, so we kill some infeasible state, that is called end state or dead state, dead states also. So we kill that dead state. That means we just stop some more combinations we avoid some more combinations. So we can able to reduce the number of combinations to be checked to find the all peaceful solutions. So this is about sum of subset problems. So here still we can able to reduce the time complexity. So the simple trick is, so instead of solving the problem as it is, we can able to sort this input in descending order. Suppose if you sort the input in descending order, so it will give like this. The input will be so 34, 12, then 5, then 4, then 3, 2. So if you use this sorted descending order sorted array, then we can able to do some early pruning. So pruning here, pruning means finding the death state. So we can reach death state earlier. So in this case, the 34 is cannot be included to our solution. So it can be found after the second level of explosion. But if you sort it in a descending order, then we can do some early pruning. So early pruning means if you do such early pruning in our solution, then the level of your final solution can be reduced. So in this case, the final solution level, so this is a state space tree. So this is level 0, and this is level 1, and this is level 2, and this is level 3, and this is level 4, and this is level 5. Finally the solution we find at the level 6. Suppose if you sort this input in a descending order, then we can able to reach the final solution, the possible solutions in the lower level itself. So now you can solve this problem by the descending, by sorting this array in descending order, and find at which level you reach the final output. Thank you.